Welcome to the live stream for the Ariane 6 launch vehicle, which this is going to be its maiden flight. So this is the first time that it's ever going to be taking off and hopefully getting to orbit. A little bit of background on who I am. I'm Josiah. I'm the chief engineer at Astra. That's a student rocketry group that's based out of Bremen. Actually, curious fact, Ariane Space is actually here in Bremen. They do have offices here. So we do have some people that we know and colleagues that have actually worked on this rocket. So it's good to see finally that it gets to hopefully launch today. This has been a long-awaited mission for sure, especially if you're a European and you're in the aerospace world. The Ariane 6 has kind of been bouncing around for probably about a decade, and they've been targeting launch for basically the last 5 years. So it's long anticipated, and we're hoping that we will have a successful result today. And maybe we can see the European space market, in terms of the launch market anyway, starting to expand again. It used to be really strong 10 or like 15 or 20 years ago, and it was quite competitive, but it's kind of fallen off lately, and I'll kind of get into more of that later on. So the question is, will the Ariane 6 be the vehicle to do that? But regardless of that answer, it's at least the next step in the journey for European rocketry. So, yeah, hoping for a good launch today. I have high hopes because Ariane Space has definitely ticked all the boxes and made sure that everything is working and kind of. They've done so much testing on this vehicle that you just can't imagine. They literally test everything. So it's a little bit different than the first launch of like a startup rocketry company where they don't really have much experience with this type of work and building rockets and getting to orbit. Ariane Space is quite mature and experienced, I would say. So it does increase the chances that they'll be able to get this vehicle off the ground. Yeah. Anyways, you might be wondering why I am interested in streaming this. Like I said before, I'm part of a student rocketry group called Astra. We, of course, in the future would like to maybe work at these companies. So it's always exciting to see what they're up to. Also, sometimes they try out new ideas and designs that maybe might be useful for the world of amateur rocketry. So sometimes you can get some ideas that are interesting, and you can get inspiration from what the professionals are doing. If you're interested in what we do, we are building rockets, not like Ariane 6, much smaller rockets, but our goal is to try to get a rocket that will fly to space. And this year we've been developing a test project for that, which is a rocket that is just going to go up to 10 kilometers. But a lot of the technology that we're going to use to get to space will be in that rocket. Yeah, we've basically been, for the whole last year, we've been working on it, developing it, building it, and testing it. We've actually finished all of our propulsion testing about a month ago. And yeah, we're getting ready to potentially have a launch. So that's kind of an exciting development for us on our team. And we've internally been having kind of an inside joke going on, wondering who is going to launch first. Is it going to be Astra or is it going to be the Ariane 6? So it looks like the Ariane 6 beat us to it. Of course, we won't know if it really does until we see it take flight today, but I think that we may have lost that one. So, just to give you an idea of the timing of today's launch, the launch window actually technically started about 5 minutes ago. They have a 4-hour launch window, so it goes from I'm streaming from Germany. It's 8 p.m. here right now, and that extends all the way till midnight. So they have a 4-hour launch window that starts 5 minutes ago. I think they're targeting to launch probably sometime in the next hour, but we'll have a more of a clear idea of that once they start up their stream and we kind of figure out where they are in the process. It's mostly a liquid vehicle, so they do have to fill liquid hydrogen and oxygen into their tanks and stuff, so it takes time. And of course, this is a new vehicle, like I was saying, so there's gonna maybe be some hiccups or kinks along the way, so they'll take pauses probably. So be prepared to not get too excited when you see that clock stop. It's just going to be part of the process. So I mentioned that we have the 4-hour launch window. They're launching this rocket from South America, from French Guiana. If you're familiar with Ariane Space, that's kind of like their launch site. The reason why they launch from there is because there's a lot of advantages in terms of getting payload into orbit. If you're launching near the equator spins faster because it's wider at the equator, so the speed that you have just because Earth is orbiting is faster. And that gives you a little bit of a boost and helps you, pushes you along to orbit because you're trying to get velocity. And that extra little velocity that Earth's rotation gives you kind of helps. And on top of that, it's also helpful for getting into geostationary orbit, because in that orbit you actually want to be like close to the equator, so you orbit around the equator kind of. And if your launch site is way up in the north or way down in the south, it's tough to fix your orbit to turn it into one that is kind of flat and in line with the equator. So it's kind of a unique place, and they have their specific reasons for why they launch all the way over there. Obviously, it's very far away from Europe. So, but yeah, if you're confused about like, the sun being up or something, because the sun is kind of about to go down in Germany, but of course it'll be early afternoon there. So, yeah, their stream is expected to start up in about 10 minutes or so. So we'll just hang out until then. Maybe we'll go over some of the specs of the vehicle and what makes it different. From the Ariane 5, of course. This is a iteration of the Ariane 5 vehicle, so this is the next generation. It's the next evolution of the vehicle. So obviously they've made some improvements. So what are those improvements? That's the question that we'll try to answer. So the vehicle it comes in two configurations. So it has one configuration where it has like a core stage with two of those side boosters, kind of like the old style Ariane 5. If you remember, Ariane 5 also has two side boosters. So Ariane 6-2, which is the one we're going to see fly today, is kind of just a mini version of the Ariane 5. It kind of looks the same, but it's actually slightly smaller. And if I think I have a picture that compares the sizes later on, but it has the same main body diameter. It's using the similar types of engines, using liquid hydrogen and oxygen for the core and the upper stages. And of course it has those side boosters, which are just powered by solid propellant. The vehicle doesn't quite have the same capacity as Ariane 5 did. It actually, with the 6-2 version, it actually has less capacity. It only can get 10.3 tons to low Earth orbit and only 4.5 tons to geostationary orbit. That is an interesting design choice from Ariane Space's perspective. I think they've realized that a lot of the payloads that are launching today aren't these big giant satellites that they had in the past. So they're trying to evolve and get into the market where they can offer maybe cheaper prices for a slightly smaller vehicle. So we'll see if that pays off for them. Can you give us an update on Suzy, and are the strap-on boosters recoverable on Ariane 6? So those two boosters that are on the side are indeed not recoverable. In fact, the whole vehicle is not recoverable. And this personally is like my biggest gripe with the whole design of the Ariane 6. I am very passionate about the launch industry evolving towards reusability. So it would be nice to see future vehicles that are being designed, especially by big companies like Ariane Space that have lots of money to do this kind of stuff. It would be nice to see them trying to move towards a reusability solution, but right now Ariane is not really in that mind, I would say. So the vehicle is completely expendable. There's no recovery that will take place. Yeah, there's also a second version of the vehicle. Like I said before, it's this Ariane 6-4. Sorry, the picture there is actually wrong. But imagine it has four boosters. That's the only difference between the two of them. So whether you have 2 or 4 boosters. In this configuration, it can do basically twice the payload to low Earth orbits and a little over double the payload to geostationary orbit. So this will be obviously a more expensive version of the Ariane 6, but it can kind of deliver similar to slightly higher specs that the Ariane 5 could. So this is like the super heavy version. Yeah. So with these two configurations, they kind of have a lot of options that they can play with. Ariane 6-4 allows them to still do the same kind of missions that Ariane 5 was doing, and Ariane 6-2 allows them to do maybe some more of the modern types of missions that don't require such giant, huge satellites, because a lot of stuff is getting miniaturized these days. So that's kind of the overall idea of how the dimensions are. All right. Someone's saying that the description is not correct. Yeah, that's possible. That might be that's my mistake. I think I just potentially copied something that was already in the OBS software. Apologies. This is the Ariane 6 launch. Not there's no James Webb Space Telescope. That's already up in space. So maybe I can fix that a little later, so that people don't get confused. So the question is, why is Ariane developing the Ariane 6? So I can kind of paint a good picture of that here. This is a picture of the launches of the Ariane 5 over the past 25 odd years or so. And you can see that it was quite a prolific launch vehicle about 15 years ago. It was doing, 5 to 10 missions per year. And it was doing really big high-profile missions that's, bring a lot of money for the organization. Things like, James Webb or big communication satellites that go to geostationary orbit. But unfortunately, over the past 5 years, you can kind of see this graph. The orange is Falcon 9 and the blue is still Ariane 5. The Falcon 9 has kind of taken over in terms of performing the missions that Ariane 5 used to perform. So they're kind of not competitive anymore. And that's why we need this Ariane 6 vehicle. So the idea is that the Ariane 6 is hopefully going to lower the cost and allow for more competitiveness against SpaceX. Essentially, that's kind of the core methodology, I would say. And so here you can see the comparison between the two. This is comparing the 6-2 Ariane 6 and Ariane 5. So you can see that Ariane 6 doesn't quite have the same payload as Ariane 5 does in this configuration. But if you look at the cost, it's half the cost. It's only $75 million. And so that's going to be the place where potentially Ariane 6 can be competitive. And if you compare it against the Falcon 9, sorry, I'm throwing a bunch of stats at you here. But the Falcon 9 right now costs around $72 million. So a $75 million Ariane 6 is kind of starting to be in a place where the vehicles are starting to look like they could compete with each other. Unfortunately, Ariane 6 doesn't quite give the same mass to low Earth orbit as Falcon 9 can, but Ariane 6 also has a bigger nose cone volume that it can put payloads into, and you usually run out of volume inside of a nose cone before you run out of mass in most satellite applications. So it could be that Ariane 6 can actually do a lot more useful payload to orbit than Falcon 9 can. So it kind of will depend on the satellites that are being launched and what missions are being performed. So that's kind of the placement of Ariane 6 and the whole evolution of what's happening here and why Ariane 6 is coming and why it's important that Ariane succeeds in this next couple of months, especially on this launch, because if it's able to, then it can really change the way the industry is shaping up in terms of contracts and stuff like this. So maybe it helps Europe get back on the launch scene. We'll see. All right, let's check to see. I don't know if I guess the live stream has started. Just let me turn on the stream here. I don't think we have any audio right now. but it looks like we're about 44 minutes away from launch. So you can see the clock there up in the top right-hand corner. It seems to be counting down to 9 o'clock Germany time. So that's going to be 4 o'clock at the launch site. So maybe we'll see a launch in 45 minutes. But like I said before, don't get freaked out if the clock stops or if the clock changes, because it's very likely that there could be stops, or, you know, this is a new vehicle, so there could be small things that are not correct that need to be changed. So yeah, don't bear with the process. Don't disappear just because of some small things that might happen. All right. Yeah, manned space flight if the Ariane 6 is successful. So right now the Ariane 6 is not man-rated. Ariane 5 was man-rated, I think, at one point. But I don't think Ariane 6 is going to be man-rated, or I don't think there's a plan for man-rating it. But don't quote me on that. I think they're mostly targeting trying to just launch payloads to orbit. Right now, Europe doesn't even have a capsule which it could launch, so there's not really a reason to man-rate it at this point. But I imagine in the future that could change. I mean, the payload capacity of the 6-4 is like 20 tons, which would be enough to launch a capsule if it wanted to. So that there's that to be said for that. I think that they would have to do more work on the emergency escape infrastructure and things like that. And they would probably have to beef up the engine on the second stage. One of the problems that you have with a man rating process is that you need to make sure that the vehicle has enough sideways velocity in all parts of the launch trajectory in order for the vehicle to be safe. And the reason for this is that when you're coming, like, let's say there was a problem and Ariane 6 blows up, like, you know, halfway to orbit. And so they activate the emergency rockets that get the capsule away from the vehicle, and then it has to come back to Earth, and it just comes back ballistically. And if you're coming in at too steep of an angle, there's so much G forces that occur because of that it's like really uncomfortable and potentially dangerous for the capsule and also for the people on board, because people can only take so many G's, you know. So because of that, you need to make sure that your trajectory is more suitable for human passengers and for capsules like this. So it's a bit more complicated than just like putting the human rated stamp on it. Like, you have to sometimes make design changes that change the capacity and the specs of your vehicle, and that also requires testing, and so it takes time. It can be complicated. So I wouldn't get too. I don't think Ariane 6 will be man rated unless there's like a serious need to do it because Europe develops a capsule of some sort. Yeah. So the cost that Ariane 6 is right now is comparable to the Falcon 9. I would point out that I don't think that SpaceX is actually charging a rate which is, like, in their mind competitive, if that makes sense. I think that they're kind of gouging the market right now because there's no reason for them to lower their prices because there's no one to compete against. So I think the Falcon 9 is way cheaper than the sticker price that you see on the vehicle. Like, they're using all those first stages. They're cranking out those second stages like one a day, assembly line process. I can't imagine that vehicle is actually 72 million. I bet you they're doing it for like 30 or 40 million, and they're just taking the profit. I mean, why not? They're the only game in town, and they offer the lowest price. So if they have no competition, then they have no incentive to actually compete. And this is why it's very important for other companies to develop vehicles that can compete with SpaceX, because otherwise the cost of space will actually not get less. It'll just stay high because SpaceX has no incentive to lower their costs. Uh, yeah, it's. I mean, they're a private company, they're a business, they're trying to make money, so it's like, yeah, I get it, but this is why we need competition. That's the free market only works if there's other vehicles that can steal contracts from SpaceX, and then they have an incentive to try to lower their prices. Yeah, the same kind of thing was happening like 10 or 15 years ago when it was just ULA, and ULA was doing all the launches, and SpaceX was like the company that went in and shook everything up. But now SpaceX has kind of become the new ULA, so they need to be shaken up. Maybe Ariane 6 will help them with that. We will see. But yeah, there are also some things that make the Ariane 6, quite cheap. I mean, they're using mostly a tried and tested architecture. So, I mean, if you just look at the vehicle on the pad there, I mean, it looks pretty similar to an Ariane 5. So, they didn't have to like reinvent the wheel to build this vehicle. Um, yeah, and they've also kind of, how shall I say, they've optimized a lot of the manufacturing processes that they use for a lot of the parts of the vehicle, so they can do things cheaper than they could on the Ariane 6. A lot more 3D printing, stuff like this. So they're able to make like engines and stuff and these kind of things for a lot cheaper. And usually that's what's driving the cost for vehicles like this. Is the Ariane 6 capable of carrying payload and docking with the ISS? Well, the Ariane 6 can certainly carry payload. There's no question that that's possible. If you want to dock with the ISS, though, you have to have like a capsule that can dock with the ISS. And obviously, Ariane 6 is just a launch vehicle, so it would launch something that maybe could dock with the ISS. That would be possible. So maybe if like a company came and approached Ariane Space and said, "Hey, we have this contract to resupply the ISS with some cargo or whatever. Can we put our spacecraft onto Ariane 6 and launch it to the ISS?" That's totally possible. And that's kind of how it's kind of how things could work. But usually the company that does a launch vehicle also makes the capsule, and I don't think Ariane Space has any interest in actually making a capsule to do something like that. But maybe there's another company in Europe. I know one. There's one company called the Exploration Company. It's actually German. They operate out of Munich, I believe, and they're developing a capsule which can resupply the International Space Station. Yeah, I don't know exactly where they are in their process, but it's something that potentially could fly on Ariane. We'll see. Maybe you'll see one of their capsules doing something like that. Yeah, could be an exciting time. So if you're just joining, I'll just recap exactly where we are in the process here. Right now, the Ariane 6 is just sitting at the launch pad. They say the live coverage is going to start in 5 minutes. I am not sure, but we will see if it does. It's being broadcast in 2 languages right now, French and English. We're on the English stream right now, so I hope that they actually are going to stream in English. And it's not going to be like the Japanese launches where you don't see much English. We're about 35 minutes away from launch, according to their clock right now. But please bear in mind that this is actually kind of a big launch window. The window extends for 4 hours, and we're actually already in it. It started about 25 minutes ago, and it extends all the way for another 3.5 hours. So it's just a test mission. There's no actual payload on the vehicle. It's just like a test payload, and they're going to launch it basically straight east and see if they can get into orbit and perform all the functions that they need to perform with the vehicle. It's also, keep in mind, it's a maiden launch, so there are things that could go wrong along the way in the clock as it ticks down to 0. So there could be pauses that they take, or maybe they have a hold, but they have a whole 4 hours to work things out. So we just have to be patient with them, and hopefully we'll get to see the Ariane 6 take off. Yeah. We're all very much looking forward to this vehicle taking off. It's been a long time coming. This vehicle's been in development for the better part of the last decade. And it's had we're launching next year marketing coming out of Ariane Space for like the last 5 years. So it's good to finally see that it was able to get to the launch pad. There are also a bunch of other companies in Europe that are developing rockets, but none that are developing a heavy lift rocket like this one. So Ariane 6 is, at least the one that's launching today, is technically a medium lift rocket. It does about 10 tons to low Earth orbit. But the 6-4, which is a variant of the Ariane 6, where it just has 2 extra boosters on it, that one is a heavy lift vehicle. So it's the only heavy lift vehicle that exists in Europe. And actually right now it's actually the only vehicle that exists in Europe. But that will change soon. There are 3 companies in Europe, in Germany that are developing small lift rockets. And there's also a couple companies in the UK that are developing some small lift rockets as well. So maybe in the future we'll get to see their first launches as well. By the way, if you guys have any questions or stuff about the Ariane 6, please feel free to ask. I do know some things. I'm not an expert in all the systems of the vehicle, but in terms of the overall design, there are professors that we have that's designed the rocket in our master program. So sometimes that's cool to get some insider information about how stuff works. Is the Vulcan engine on the first stage carried over from the Ariane 5, or is it a new engine? As far as I know, it's basically the same engine. So I think they've made some upgrades to it and stuff, but it's basically like the same build and the same techniques that they use. So it's still the big powerful 1.3 megawatts, or sorry, not megawatt, 1.3 meganewton engine running on liquid oxygen and liquid hydrogen. And that's it's actually one of the advantages of the Ariane 6 is that it is so efficient because of that. Obviously, liquid hydrogen and liquid oxygen are the most efficient rocket fuel that is there. So it allows it to perform missions that can get a lot of delta V, and that's basically like what measures how far you can go once you launch the rocket. It's good for missions that go to like other planets and stuff, which is why James Webb usually launches those types of things. Sorry, not James Webb. I'm getting mixed up. Ariane 6 launches those things. James Webb is an example of that because it had to go way out into a Lagrange point, and usually rockets like Falcon 9 are not actually very well designed for that, because they run on RP1 and liquid oxygen, which is not quite as efficient. Could I talk about the propulsion system of the rocket? It would be helpful for the examination. Is there a propulsion exam coming up at the University of Bremen? I guess I could talk a bit about the propulsion system, but maybe we listen into what's going on here at the launch site when it starts up. On Friday you have the exam. I don't know if I can help, if talking about the system will teach you much for the exam. But what I can say is that the Vulcan engine is, of course, a liquid engine that runs on liquid hydrogen and liquid oxygen. I believe that it is a gas generator cycle that it uses. So basically it has a pre-combustion chamber where liquid hydrogen and liquid oxygen react, and they make energy, and that gets pushed into a turbine, and that powers the pumps that push the hydrogen and oxygen into the combustion chamber. It's kind of a, I wouldn't say simple cycle, but it's like one of the simpler cycles that you can have. It's not the full flow stage combustion that SpaceX uses with the Raptor engines. So yeah, but it's reliable and it works really well. What's a more interesting engine is actually the one that's on the upper stage. It's called Vinci, and that one uses an expander cycle. So this is kind of a cycle where instead of using like a pre-combustion chamber to generate heat and heat up gases to get the turbine spinning, it actually just uses a bunch of cooling pipes that go around the nozzle, because the nozzle gets like really hot. So these cooling channels take the liquid hydrogen, and liquid hydrogen absorbs the heat from the nozzle, and it turns into a gas. And that gas is just piped to a turbine, and that turbine spins the pumps. So it's kind of like an even simpler thing than a gas generator, but it's also like really, really efficient. And it's also great for like engine cooling, because obviously you have liquid hydrogen that's flowing into the combustion, like around the combustion chamber and the nozzle. So you can actually like, it's totally possible to have combustion chamber pressures that are greater than 3000 Kelvin, and your nozzle won't melt. So that's always great.
Europe's newest rocket, Ariane 6,
here we go.
is on its newly built pad preparing for its first journey into space. We have a stack of passengers on board from experiments and CubeSats. They're up there in the fairing to re-entry capsules waiting to lift off in half an hour. The countdown on the top right-hand side of your screen there. And over in mission control, which is about 15 kilometres from the pad, the nerve centre of operations, the teams inside what we call the fishbowl, that protective glass, are going through the final preparations before launch. Right now the boards are all green. That's a good sign. We are go for launch. I'm in the commentary box here with Tina Buchner da Costa. Tina is a launch systems engineer from the European Space Agency. And in the French commentary box, we've got Lisa Peterson and Luce Fabregat. Tina, it's great to have you with us. You've been helping to design and test the system, so this is a really big day for you.
Absolutely, Katie. I am so thrilled to be here with you today, and I still can't believe that today is really the day we have all been waiting for. My rocket engineer heart is pumping loads of adrenaline in my system right now, and I can tell you that I share this incredible excitement with all my colleagues who have been working so hard to prepare this moment.
Yeah, it can't be understated how long that we've been waiting for Ariane 6. So everyone is excited, especially the people that designed it. Yeah, I'm not sure if there's much more I can say about the propulsion system. I mentioned the Vinci and also the Vulcan engine on the bottom, but they also, of course, have the side boosters, and those are not liquid engines; they're just solid engines. So there's solid propellant, and that means that the fuel and the oxidizer are like mixed together and in a solid form, and you just ignite them. And of course, there's no going back when you do that, because you can't stop the combustion process after that started. So once you light those solids, the vehicle has to go up. Yeah, the software and the navigation and the guidance, navigation, and control are definitely just adapted from Ariane 5, 100%. I also would expect that they've made some mass optimizations, and that's probably another reason why the vehicle gets cheaper, is because I would expect they've made some improvements on these systems that allow them to do things in a cheaper way and potentially more reliable way as well. I'm not a huge expert on the avionics side, so I can't really speak to the to the changes that they would have made, and also I don't think they would release the details of these things, because a lot of that stuff is like proprietary and trade secrets of Ariane space. Yeah. Can the Vinci engine be reignited? That's actually a great question. I don't actually know if it can be. I would expect that it should be able to. I doubt they use TTEB. I haven't seen it do that before, but we should keep an eye out and maybe listen and see what they say about it. Yeah, that's actually a good question. In most cases, they would never need to reignite the engine though, because usually they just like go straight into an orbit, and that's kind of it. So I kind of doubt it can be reignited, to be honest. Could we see the rocket from Bremen? No, I highly doubt it. The launch is coming from French Guiana, so it's gonna go basically straight east from there. So it's gonna stay between -5 and +5 degrees north and south of the equator. So like if you're way up in Germany, which is at like 50 degrees north, you're definitely not going to see the rocket. Yeah, that's...
This is especially true for the upper stage and all the ballistic phase, because there's only so much that you can actually test on Earth.
Indeed, and you and the teams have been practicing with a test model of Ariane 6. So I wonder how it feels, Tina, to actually have the real thing on the pad today.
Well, you hear my voice vibrating for a reason. It's super exciting, but on the one hand, it somehow feels like a déjà vu, because we have indeed done quite a lot of thorough testing, and we repeat today what we already did several times. We have tested all the systems, and we have, of course, tested the engines on the ground. But this time, when we ignite the boosters, we will have to let our baby go. And I can tell you the concentration.
Another little factoid I can give you is that we actually test our rocket in the same place that Ariane Space tests their rockets. At DLR Lampleshausen, which is the place that we test. Of course, we're not on the exact same test site. We're at a different location on the same facility. But sometimes you can hear the big tests that they're doing from our test site. So it's always cool to have that feeling like you're a little bit closer to the professional engines. Yeah, but the last campaign we were the noisiest rocket there. So
passengers on board the bus, and they need to go to different destinations. So we will test that.
Organisations across Europe have come together to build Ariane 6 and guarantee Europe's continued access to space. Let's find out more now about our new rocket, Ariane 6.
yeah. So to give you an idea of how Ariane 6 actually gets built, like they build, because it's kind of like a European thing, they build a bunch of stuff all over the place. So some stuff gets built in Germany, some stuff gets built in France, some stuff gets built in other European countries. They all have a bunch of subcontractors where they get parts from and stuff. So it's not like SpaceX where they like build the rocket in like one warehouse and then like go to the launch pad. It kind of all gets assembled together from various different places, which is kind of a different philosophy than companies like SpaceX work on, where they just have all of the stages of production basically and they're under one roof. That gives them a little bit of an advantage because they can kind of rely on experts on certain systems. So they don't need to like figure all that stuff out on their own necessarily, but so they rely on other companies to supply them with things that, and maybe more efficiently than other people could have done it. Could Ariane 6 be used for a Moon or Mars mission? Yes. Ariane 6-4 I think would definitely be suitable for that kind of a mission. If we go back to the payload capacities, like if you launch an Ariane 6-4, you can get 21 tons to low Earth orbit, but you get 11.4 tons to geostationary transfer orbit, and potentially you could get something on the order of 9 tons to like a lunar transfer orbit, and probably something on the order of like 5 or 6 tons to a Mars transfer orbit. So if you wanted to launch something really big to Mars, like on the order of 5 tons, you could do it with something like an Ariane 6. So that would be something like a rover or something. Usually the rover missions, I think their payload is coming out to around like 3 tons or so. So it's possible. It's possible. If like Europe wanted to be like, we're going to do a Mars mission, you could definitely pull it off with an Ariane 6-4. What might be more interesting though is maybe for like missions that are even further out than that, because it has such a high delta V capacity because of the really efficient engines that it has. You could like put a kick stage on top of that, on top of a 6-4, and you could probably launch something pretty heavy all the way to like Jupiter or Saturn, which is interesting in my opinion, because I think these places are very underserved in terms of missions for probes and stuff. Like there's so much we don't know about Jupiter's moons. We need to send more missions there. There's all kinds of cool geology and stuff that's going on there, and who knows, there could be things like signs of life and things like this over there that we're just completely unaware of because we don't send enough missions there. But yeah, Ariane 6 could do something like that, and also for a pretty good price. Like doing a mission like that and only launching for 125 million, which is the price of the 6-4, like that's a bargain. But yeah, if there's any aspiring teams that want to do something like that and petition the government for some hundreds of millions of funds, definitely do it. I think it's worth it. I would wish that governments would be more amenable to investing in these types of missions. I know that there's no like payout in terms of like monetary value. Like there's no profit when you send a probe to like Jupiter or to Titan or something. Like you're not going to get any profit out of that, but the value that you get from inspiring people and getting people excited about science and about STEM fields, I think that pays out in the long run, because those things are what generate innovation and new ideas, and that's where you might get a return on your investment. But it starts with doing ambitious and cool things that inspire people.
We're looking here now at a movie to show some of the stages. What happened? What are its main features?
So everything started with earthworks and excavation of this 28-meter deep hole. This is where the launch pad now has its flame exhaust ducts. And here we see the start of the rail work for the mobile gantry, so this colossal Eiffel Tower on rails. The building that is used to actually access all the platforms. And you remember, Katie, we've been in there.
Yeah, very impressive.
Several floors. Here we see the steel structure actually being built in a time lapse.
It's crazy how they built this like in the middle of the jungle.
Of the movie here, you see the water tower that is actually used to damp the noise at liftoff. And on the right side, you see the exhaust flame ducts for the boosters. Huge concrete structures, actually.
That's where all the flames of the fire comes out.
Yeah. This here is the assembly building for the 2 stages. Now we do that in horizontal integration, which reduces the cost. And here we see some pictures of the installations for the propellant storage, handling and transfer. There are thousands of components and valves, and actually a lot more than what we see here is underground. Quite impressive galleries.
Quite a labyrinth under there.
We have a look here at the water pool, which is equipped with the spark igniters. This is where we burn the hydrogen from the line's cooling process or when it evaporates during filling operations. And here we have a quick look at the water system test. And the water is actually being recycled after every launch. And to finish, we see a mock-up that was used to train putting the rocket in vertical position. And finally, the cherry on the cake for the launch system was the long firing test we did last year in November, where we qualified the main stage flight.
It's crazy how much work they've done.
Hot fire test, as it's known. So we have a number of passengers on board the bus today, sharing their ride. All spacecraft, of course. We don't have any people on board. The biggest one is about the size maybe of a satellite dish, and the smallest one is the size of a little box of matches that you could fit in your pocket. We have satellites from commercial companies, space agencies and universities, and they range from established players like NASA to students designing their first ever satellite. And most of them, well, they're testing their technologies, aren't they, to check that they actually
So there
work in
are student
space,
groups
right?
that are actually
Yeah, we do have lots of,
launching
lots
payloads
of
on this
different
mission
fascinating small
as
spacecraft
the test
on board,
payload.
indeed. Some are detecting gamma ray bursts, so the most powerful explosions in the universe. Some are tracking.
And actually, on that point, this is actually a really great opportunity for other student groups, by the way. So if you're in a student group, I highly recommend that you look at rockets that are doing their first launch, because oftentimes they don't actually have real payloads, because no one wants to launch on a rocket that we don't know what's going to happen, and we don't know if it's going to work or not. So if you just approach some companies that are going to perform a first launch sometime in the next couple of years, you could probably, if you just make a good case, you could maybe get on as a payload of one of these missions, especially if it's from like your home country. So like if you wanna develop some thing that would be launched into space and you want to test it and learn about how to build things for space, I think that's a huge opportunity. I said before that if you're in Germany, there's 3 companies right now that are developing vehicles that are hopefully going to be orbital in the next couple of years. So that could potentially be a big opportunity, maybe, if those companies would be willing to work with student groups and use them as the guinea pig payloads. So if you're watching, that is my recommendation.
Some routine checks in the ground segment equipment happened earlier this morning. Yeah, but it means that there's still plenty of time to fix any glitches if a panel turns red.
It's nice that
We
everything's
have
green
a
right
couple
now.
of control rooms on the job today. We have mission control, which is what we're looking at. We're, I don't know, 15 to 20 kilometres from the pad. A bit like the air traffic control tower at the airport. And closer to the pad, we have launch control, a bit more like the cockpit of the plane. Of course, the rocket does go on autopilot after liftoff. Tina, this is your home.
Indeed, this was my home the past month.
You've been there this morning?
Yeah, so this is where we actually get the launch pad and the launcher ready for liftoff. There are 2 teams working here in very close interaction. This is the team doing the actual operations. So these guys are having their hands on the rocket and on the pad, opening the valves, sending in the fuel, switching systems on and off. And next to this room, there's the room for the design authorities, as we call them. So the people who designed the system. Here we have them. This is where I would be sitting. So they see each other and they're separated only by a glass wall. During operations, the designers monitor what is happening in the systems in real time, checking temperatures, pressures, currents, and they see immediately when something looks a little bit unusual or when things go slightly off track. And then they meet and troubleshoot in real time. So this is here what we call on site the bazavant. And they are supported by engineers who actually have the exact same information that we have here in French Guiana, back in Paris, close to Paris. Here they are in Space Code. So all of them belong to the design team in Ariane Group, and they are actually the support office base arrière. It means we can engage more brains to solve trouble if we have some.
The more brains, the better. I wonder how it feels to sit in there, Tina.
It's an absolute dream job.
Right, we have the last weather check coming up. There's our rocket, Ariane 6, standing tall on the pad. We are actually on the Amazonian coast of French Guiana in South America. It's hot, it's humid, it's been raining.
So we don't see, I think the vehicle is all filled up already. What's interesting is that you don't usually see the big vapor clouds like you do for, like if you're watching a SpaceX launch or something. I think that the Ariane 6 has a lot better insulation that they use on the vehicle, so they can kind of get away without doing so much venting.
As I said, it's been raining this morning, otherwise it would have melted.
But there are actually a lot of other things that we need to monitor as safety is paramount here at the base. So several weather checks.
But everything's ticking away here.
The first one is made before actually removing the mobile gantry, so that was fine. We rolled back.
I expect that
actually look at the wind on the pad.
It's looking a little bit overcast and stuff, but usually the ground weather is not quite so important. It's usually more the high altitude winds and stuff that are the problem. And I think that right now it's looking pretty good.
And for safety reasons. And we also look for lightning risk.
Yes, that's important too. And how do we find out about the weather?
So here we see the weather station here in Kourou, and they are launching weather balloons carrying instruments that send back information on atmospheric temperature, pressure, and humidity. And at the same time, we also have sensors around the launch base and at the coast for wind and for lightning. And here we have a look at the launch pad. We can see that we have 4 huge lightning masts, so we are protected on the pad in the case of lightning. But of course, once we lift off, we have to be sure that there's no lightning risk once we head out.
Tina, you've been working here on site for, some weeks, I believe, and some of your colleagues have been here on the base for months, getting ready for today. So I'm guessing that you all get to know each other pretty well. We call this process of preparing the rocket and the spacecraft the launch campaign, and there are a number of different things that happen during that time. So Tina, just run us through some of the main events of the launch campaign.
So we have a brand new cargo ship, which is called the Canopy. It's a hybrid wind-powered sailing boat, and this one transported the rocket stages from mainland Europe to French Guiana. It was end of February this year, and then they were transported by road to the spaceport into the final assembly building. So here we do the horizontal assembly of the main and the upper stage.
This is one big
and we also
change
connect
from
the fuel connectors,
Ariane.
for example.
Ariane
So
5
what you see
is
here is actually
the horizontal assembly.
The ULPM, it means the upper stage that is rolled in first, and once we see here both stages being mated. And once this is done, we open the doors towards the launch pad, and we have an automated guidance vehicle that actually rolls completely by its own the 800 meters to launch zone, where then the central core, as we call it, once it's assembled, is lifted up and placed on the table. The boosters, they are actually prepared in a separate booster preparation building, and they are transported on their own transport means, which is a delicate operation because they are already filled, obviously. Once they are then connected to the rocket, we move over to the satellite preparation building that we see here. So here the payload stack is being prepared, and once we actually put on the fairing around all our dedicated passengers, we call the product our upper composite. And the upper composite has another dedicated transport mean. Here we see it. It's called the upper composite trailer.
They have a lot of dedicated transport vehicles for each of the parts.
Over to the launch pad. Yeah, and once the payload stack is on the launcher, as we can see here, the launcher is ready for test or liftoff.
And here it is, standing tall there today on the left-hand side of your screen. We're 6 minutes to launch now. We are live at the European spaceport. The final countdown actually started about 10 hours ago with a lot of important operations. What's been happening, Tina?
Yeah, so at 7 a.m. local time this morning, we had the rollback of the mobile gantry. Since then, we have no more access to the launcher, so we were changing our ventilation systems from air to neutral gas, and we were flushing all remaining humidity out of the system, which is important. And around 9:45 this morning, we started chilling down of the ground lines, and around 11, we actually started filling up the launcher. First the upper stage, then lower stage. Then in parallel we were pressurizing our systems and doing electrical checks, armings, getting telemetry and radars ready. And now we're in a phase that we call the topping up.
They have to do that top up because of the...
Attention pour la séquence finale lanceur.
So they're in the final checks now.
Top I0 moins 5 minutes.
So our Range Operations Manager, Raymond Boyce, has announced the final 5 minutes of the countdown, a very, very important time. We call it the automatic sequence, or the synchronized sequence, because Ariane 6 is now becoming progressively autonomous, and there are lots of really, really important operations during this time.
Look
And
at
who
the
are we
people
seeing
there.
here?
This is Limero, I think, cheering. Yeah, those operations are actually timed at the millisecond intervals. It's a very impressive list of system checks going on. It's a very exciting moment. So now the controls are actually gradually being handed over from ground to the computers on the launcher. Nobody's moving anymore in the control room because we can't.
Just to give you an idea of what we're about to see in 5 minutes. So the profile for the launch will follow a very similar profile to the one that the Ariane 5 did. When you see the ignition, the vehicle will light the main core engine, which is the Vulcan engine, and also those two side boosters, and then it's going to take off really fast. The side boosters will burn for about 100 seconds, and then they're going to separate, and then the core stage will go all the way, will take it most of the way into orbit, and then the core stage will separate, and then the upper stage will take over and push the payload all the way to orbit. Now, when the rocket does ignite at the start, the center core engine will ignite first, and it'll be burning for a while, like 5 seconds or so, and then they'll ignite those solid boosters. So don't get freaked out if the rocket is sitting there just burning the center engine and nothing's happening. That's part of the process. That's kind of how the rocket gets launched. The reason for that is you have to make sure that the core engine is working properly. So there's some internal checks the rocket is doing to make sure that the engine is like safe and okay. And then once that is cleared, then it lights those solid boosters. Because once you light those solid boosters, there's no going back. You can't you can't turn them off and recycle. So you have to make sure the rocket's ready to go. Yeah, that's kind of the way that you will see this thing take off. Also, keep an eye out for how fast it takes off from the pad. The Ariane 6 has one of the highest thrust to weight ratios of a lot of vehicles that are out there, so it really takes off in quite a hurry.
And so these massive fueling and pressurization systems, they will be disconnected and retracted at liftoff. It's a command that is sent just 300 milliseconds before we send the command to ignite the boosters. And another thing to look out for now, just before liftoff, is at 7 seconds before liftoff, the Vulcan engine will be ignited, and that allows us actually to check it is running smoothly before we ignite the boosters. And once the boosters are switched on, of course, we lift off. There's no holding us back. And another thing that you might see are the plume effects of these boosters. So the extreme heat of the booster waves onto the launch pad need to be managed. And here we have a look at Vulcan, so we will see it firing up in a minute.
We're looking right at the
Vulcan
nozzle
engine on the main
Vulcan
stage.
there.
Indeed, indeed. And we see here that we are getting a bit lonely in Jupiter too. Everyone is
Yes, all the
traveling
teams,
outside to the terrace.
everyone going out onto the balcony to watch the launch in real life. We're getting close now, coming up to the 1 minute mark. The range operations manager getting ready to call
We're
that
near
out.
to the time
À
here.
tous de DDO, attention pour moins d'une minute.
So the rocket is going
Top
to
à 0
be
moins une minute.
the rocket's going to be on its
We
own
are
power
1
now.
minute to launch. Our best wishes to all the Ariane 6 teams and everyone who's been working so hard for today. Good luck, everyone.
Go Ariane 6, gute Reise and bon voyage.
Ariane 5 was one of the most reliable vehicles that was ever made. So hopefully Ariane 6 will continue the tradition of reliability. And I hope they get some good tracking camera shots, regardless of the fact that there's some overcast. Usually they don't have onboard cameras, so just keep that in mind. That's one thing that maybe they made a change.
À tous de DDO,
But
attention
usually
au
they
décompte
don't.
final. 10, 9, 8, 7, 6, 5,
Here we go.
4, 3, 2, 1, top.
And she's
Allez,
off.
2 SR, décollage.
The first flight of Ariane 6. This is looking fantastic. They should give us a better audio than this, but you can see there that the solid boosters totally overpower that center Vulcan engine, because the Vulcan is only producing about 1,300 kilonewtons, but the side boosters are producing 10,000 kilonewtons together. So it's like mostly just flying on the solids right now.
Europe's new rocket,
Pilotage calme, trajectoire nominale.
Ariane 6,
They have an
left the
onboard
pad
camera.
and is blazing a trail
This is crazy.
across the equatorial skies. The range operations
They've never had an onboard
manager
camera before.
is telling us that everything is going according to plan.
I hope they do an onboard camera with
No,
the
my heart
booster
can go up so
separation.
fast.
That would be
Oh my
amazing.
God.
Here you can totally see those side boosters are just overpowering the whole engine.
It's quite a sight.
Oh, she's coming, she's coming. Oh my gosh. This is happening.
It's the
this
most
is
incredible
really
feeling.
nice.
We have we're on the edge of tears here in the commentary box because this is a big day and a big moment.
This is their best live stream. This is the best live stream they've
Trajectoire
had.
nominale.
Actually, the building's rumbling around us now.
Wow. So you're gonna see those side
These are the
boosters
live
separate
images
soon.
From the cameras on board.
We're looking at the booster. We're looking down.
So the boosters, once they run out here, they're going to separate off, and I'm hoping they're gonna stay on this onboard camera. This is a fantastic shot. Very unusual for Ariane Space to show such nice things. I'm happy they've gone in the new direction with their live streams.
We might even be
C'est
able
nominal,
to see the
trajectoire
separation.
nominale.
We have clear skies tonight, this afternoon. We had rain all day, but the clouds parted.
I love this camera view is great, where you see just the heat of
Dots
the.
there.
So that
boosters.
separation right there.
There we see them
You can see the
falling
side
off.
boosters falling off now.
Confirmed. We have booster separation.
That looks clean to
So,
me.
Wow, that's the first clapping here that we see. What a beautiful liftoff.
And our cameras
We
on
see
board.
Propulsion nominale, trajectoire nominale.
These pictures are coming
Wait.
in with a 20 seconds delay, which is why
Ah.
we have them now.
The onboard camera is
Look at
delayed.
this,
Don't worry.
how they fall off.
It's separated
Wow.
okay.
Amazing, amazing. So these boosters, they
Oh,
have
man.
transported us 60 kilometers high.
And we can see that dot is
Trajectoire
the
nominale.
telling us that the trajectory is normal, everything going according to plan. That's the engine on the main stage that you can see there. And
Oh.
we've got a camera inside now. What are we
This
looking
is
at
the
heating?
so
Oh,
that
yeah,
was
so
the
back down
camera
there.
inside the
This was actually a
interstage.
camera inside the interstage, so we will be able to see when the lower stage separates. That's coming up. But now we have actually
man.
lost half our mass already because the boosters have burned almost 300 tons of fuel in 2 minutes
Pilotage
time.
calme, trajectoire nominale.
I'm amazed at
Everything
how
nominal.
many
And we're
cameras
getting
they have.
missions manager says.
Yes, and we're getting close now to the next thing, which will be the jettisoning of the fairing being the nose cone of the launch vehicle, which is where the passengers are sitting. And we can
Séparation de la coiffe.
Even see the, wow, that's amazing.
We had confirmation there that the fairing has been jettisoned.
Yes, so the fairing,
So they are going. This main stage is going to burn for a while. It burns for a couple of minutes. So we're gonna. I hope they keep getting the live stream from the booster though. It's such a great. Oh, what a great
Right hand
shot!
of the screen.
Look at it
and
go.
This is the live camera from orbit, and we see the fairing falling
And you
off there.
you can follow along on the right hand side. You can see the trajectory of the vehicle. It's the yellow line that's being plotted as it flies, and you kind of get a sense of the direction it's traveling also by looking at the map below that. And they also have the velocity and the position that the vehicle is at. So all the telemetry is there.
Everything going nominal. So you have altitude over time. And in the middle you see our ground track. You see exactly where we are over the Earth. And on the right side you see our altitude. We're already in 140 kilometers.
Trajectoire
distance
nominale,
away
il reste
from
moins de
where we
3
are,
minutes de
and we test
propulsion
with a
du
speed
Vulcain.
2.4 kilometers per second. And the main stage is operating.
And
It
to
is,
get
and you can see it here. It's a great big tank of fuel.
Indeed. So it is a 32-meter high cylinder, weighs 23 tons when it's empty, and it can carry 154 tons of cryogenic propellant, supporting the upper stage and the boosters. For our technical audience, we don't have any common bulkhead anymore, so we have now 2 separate tanks. And this makes the handling of the pressures a bit easier than on Ariane 5.
The 2 separate tanks also makes the vehicle cheaper. What they had before on their upper stage is they basically like nestled the fuel tank into the oxidizer tank, if that makes sense. So like it was kind of like a weird shape, and it required some very precision welding and things like this. And I imagine also it wasn't great for structural stress concentrations and things like that. But now they just have 2 separate tanks. I think that makes it a lot cheaper for them to integrate and also to design a part like that.
Had to be beefed up a bit, and we have tiles now around the nozzle, and the nozzle itself also has a new manufacturing method. So it's a more simple and cost-effective design right now.
We're getting closer now to the next phase, which is switching off the engine and jettisoning the main stage, because of course we want to lose each section of the rocket as we climb higher. The lighter we are, the faster we go. So we're separating the next stage, but that's actually quite a complex process, isn't it?
Indeed, because you have to detect first that the rocket is actually ready for separation. This is done by the guidance algorithm. And afterwards, the Vulcan engine is cut off, and 6 seconds later only we will see separation of the stage, initiated by pyro commands. And we do that by actually extending a set of springs. And the push that the lower stage does to get rid of the upper stage, or the other way around, to push itself away from the upper stage, has the same push, or the same thrust, as we call it, as the Vinci engine, but it only does that during 0.2 seconds.
The Vinci engine is also one of the most efficient engines that exists in the world. And that's because it's using the liquid oxygen and hydrogen, and it uses that expander cycle, which is a very efficient cycle in general. Interestingly enough, the weird thing about the expander cycle is that you need lots of surface area to heat all of the hydrogen that's going into the heating coils in order to go and then drive the turbine. And that means that they have to make like a comically long combustion chamber. So if you've ever seen the Da Vinci engine on display, it's like this really long combustion chamber. So it's a bit of a unique engine in terms of the world of engines.
And Vinci was ignited. Wow, that's a very.
And it
very,
looks like
very
it's
important
flying
moment
very
of this mission.
nicely.
Congrats to Bremen and to Vernon.
And we have applause
Everyone's
here.
clapping here in Jupiter.
Yep, happy faces.
There
The
you can
upper
see the
stage,
separation.
The lower stage
Propulsion
forward.
nominal.
They are on the
That looks
cameras.
great.
Wow. Will we see the Vinci engine also
Let's see this ignition here. What does that look like?
firing up? I don't know if that can be seen on the camera.
I think what's happening here is that you actually can't
Wow, this
see.
is really
We
something.
can see it. Look.
You can see
You
the
see
nozzle getting
propulsion on
hot,
the Vinci engine?
but you
as
can't
it's heating
see the propellant because,
Beautiful.
of course, it's burning liquid hydrogen and liquid oxygen, and when it burns those together, it makes water. So water vapor is colorless. So whenever you're having an engine like that, you actually can't see the exhaust, and it's especially the case when you're in space because there's no atmosphere for the water later to condense and kind of give you a plume. So literally, it's like a colorless exhaust. The only way you know that it's on is when you see that glow from the engine bell. And look at how much it glows. It's actually quite extreme. But don't worry, the engine is designed to glow like that on the end. It's made out of materials that are designed to be in thermodynamic equilibrium with the environment. So it shouldn't be a problem at all. And this is a different camera. This is
now in our
a curious
first
view.
Vinci burn phase, and we will reignite the Vinci engine twice in this mission.
So there you go.
Here for
The Vinci engine is
German
reignitable,
cooperation.
if you were
upper
curious
stage
about
is designed
that.
and built by Ariane Group in Bremen in Germany, and the engine was designed in Vernon in France, and the whole stage has been put under test in Lampertshausen on a brand new test bench designed by the German Space Agency, the DLR. And that's...
Propulsion nominale,
that was,
trajectoire
an-
nominale.
And a fun fact, the DLR in Lamposelsen, where they actually test this engine, is where we test our engine. So yeah, we definitely see a lot of each other. And of course, we're in Bremen, so that's actually where they did a lot of the design for the upper stage. The office where they do the design work is actually right beside the offices for the university. So it's all a very tight family here. But yeah, it's cool to see the stuff that was being tested over the past years at those sites where we've been testing actually flying. This is actually quite incredible. And yeah, a cool thing about space engines is that it's really tough to test them on the ground because, of course, they're designed to work in space where there's no atmosphere. So the nozzle is designed to expand the gases into no atmosphere. So they actually have this like giant. They have this giant facility in Lamposelsen, which actually creates a vacuum so that you can test these kinds of things there. Just a bit of a fun fact there.
All the expectation of our customers.
But yeah, it looks like the mission's going quite well right now. They've hit basically all the targets that they needed for the effective use of the vehicle. It's just a matter of doing the finishing touches now and getting all the way to orbit. This burn will last for quite a while. The Vinci engine is not really a super powerful one, so it does take a while for the vehicle to get all the way to orbit. But you can, again, like I said before, follow along with the trajectory, which is on the right-hand side there. The yellow line is the altitude versus distance graph. And then on the bottom, you can see the trajectory that it's making across the Atlantic Ocean right now. So, that was quite an exciting launch, in my opinion. I kind of want them to go back to the live view from the upper stage. Because I think it's so cool to see the engine glowing like that. Yeah. On our last engine test that we did, we had some issues with our nozzle getting too hot, and it would glow exactly like the Vinci engine is doing right now. But our nozzle was only made out of stainless steel, so it started melting. And you can see like sparks flying off it as it slowly erodes away. But the Vinci engine is, of course, made out of some tougher stuff, so it can handle the heat loads when it's just glowing like that. Yeah.
We call them the quick look
There we go.
team.
Exactly. Because
Keep
all
us on
along
the
vehicle
camera.
data are actually sent to the Gallet station, which is here on site. And the team that we see now here, they don't enjoy the good weather because they're actually the ones analyzing these data in real time, and they are really the first ones to know what is happening on the rocket.
And of course, they send that information, and the range operations manager.
Well, leave it to Ariane Space to deck out the whole vehicle with a bunch of cameras, and then keep switching the camera to other things. Come on.
Central Asia, and then back down over Southeast Asia towards Australia. And we picked up the signal at the Santa Maria tracking station in the Azores. We had that confirmed.
Indeed. So we're controlled by the Azores station now, and this is part of Portugal. So let's shout at Boa noite, Portugal. Thank you for helping us tracking our launcher tonight.
13,000
Pilotage
people
calme,
across
trajectoire
Europe
nominale.
have been
Fin de
involved in
visibilité
creating
par la
Ariane
station de
6.
Saint-Jean-du-Maroni.
We are just past halfway here. The velocity that we're trying to get up to is about 7.8 kilometers per second. That's the velocity you need in order to be in low Earth orbit. So we're just near the 6 kilometers a second point. So it's going to be about a minute or two more, and then that Vinci engine is going to cut off and place them into a good parking orbit. It sounds like they're going to do 2 more burns. I'm not exactly sure exactly where they're going with those burns, but I assume it has to do with the deployment of the payloads. They're also going to test out the functionality of reigniting the Vinci engine, which I think is really important because if they want to do the missions that they, I guess more missions that are more complicated, especially when you're deploying like arrays of satellites and stuff, it's good to be able to get into different types of orbits by doing multiple burns. And that's another advantage of the Vinci engine, is that it can do that.
À cette époque-là, avec les contraintes sanitaires, etc. Mais les gens étaient là, les gens.
Another thing you might have noticed is that in the graph with the yellow line showing the altitude versus the distance, you can see that the altitude has actually decreased. And the reason for that is because of the Vinci engine itself. It's not super powerful, like I was saying before. So how do I explain this with the orbital mechanics? So basically the core stage and the boosters get it into this like really steep trajectory, so it gives it lots of altitude, and then the Vinci engine is trying to push the rocket sideways more and more and more and more. But because it's kind of underpowered, it kind of has to come down a little bit before it starts going up again. So you get this like kind of a weird path that the vehicle will make. That's just the way the vehicle set up, because it's running on hydrogen and oxygen, and usually those are fairly weak engines. The reason for that is like why are hydrogen oxygen engines usually weaker? It's because the hydrogen is it's like not dense at all. Like if you look at liquid hydrogen, it has like a 1/15 of the density of water. So because of that, you can't really shove that much of it into the combustion chamber to get a bunch of thrust. So even though it's really efficient, it's actually kind of a weak thrust, and that's why you have these like weird trajectories that the vehicle will take in these situations. Where will the booster land? Well, it's definitely going to land in the Atlantic Ocean somewhere. Probably closer to the African coast. Somewhere in that region, maybe near the Azores. I don't know. What's sad is that they don't try to recover it. It's a lot more difficult to recover this booster though, because like the Falcon 9 doesn't get a whole lot of velocity before it detaches the second stage and then comes back and lands. It's usually only going about like 2 kilometers a second maximum, like 1.5 to 2 kilometers a second. Whereas the core stage of the Ariane is going much faster than that. So it's going something on the order of like 3 or 4 kilometers a second. So in order to recover that, the energy that you would need to, like when it re-enters the atmosphere, it would probably like burn everything up. So they'd have to like change the way that they actually designed the vehicle so that the second stage is more beefy. And like I was saying before, the second stage is really weak. It doesn't have a lot of thrust to be able to get itself into orbit properly. It has the efficiency, but not the raw thrust. So it doesn't really work with the engines they have to build like a reusable system with the Ariane 6 architecture. They'd have to change the entire architecture. So yeah, that's kind of a long-winded story as to why Ariane 6 can't be recoverable.
Clapping here in Jupiter, congratulations.
But right now it looks like the engine shut off properly, so
and we are where we
is
should
good.
be at a speed of 7.56 kilometers per second, as you can see
Nominal.
here. Everything nominal. 350 kilometers, sorry, of altitude.
And travelling at nearly 8 kilometres per second, ladies and gentlemen, boys and girls, per second. And so that's the first major
L'orbital
accomplishment.
tête à l'extinction du Vinci est nominale.
Everything nominal.
Everything nominal. So that's happy faces all round.
Yes, and this is actually where Ariane 5 would stop its mission. We could be now on a transfer orbit to geostationary orbit, but with Ariane 6 we actually plan to take the mission further and reignite the Vinci engine, and this will allow us to travel to a second orbit.
So we're going to be taking a break in a minute.
So that's actually what you just mentioned there, that the Vinci engine is going to be doing a second burn. This is actually the advantage that it has, because now it has the ability to be able to deploy multiple payloads into different orbits. Whereas with the Ariane 5 architecture, it couldn't do that. Like it would just, launch one thing, and then or it had a special system where it could take 2 payloads to geostationary transfer orbit, where they could like sit in the payload and be deployed separately, but the engine couldn't move them into different transfer orbits, if that makes sense. So like you can't have a bunch of CubeSats that want to go into one orbit and a satellite that wants to go into a different orbit. Whereas now, because of their reignite possibility, they can do those types of missions, which is like, I would say, when you're doing ride sharing missions, that's like the main type of thing you have to do. And right now, like SpaceX, that's like their bread and butter. Like they're always deploying multiple payloads all over the place. So it's this is another way that they're going to try to compete with and win launch contracts for these types of missions. But yeah, so far everything is has worked perfectly, and the vehicle is working well. I think that they're going into a bit of a pause here. So yeah, so it's good. They're going to wait for I think a half an orbit or something before they're going to go and reignite the engine and deploy some payloads. So maybe in the meantime,
Orbite atteinte à la fin de la compensation. APU est normal.
looks like everything is nominal, so that is good. In the meantime, maybe we can just discuss a little bit about, I don't know, if you're curious about what Astra was doing in its testing, I can give you a sneak peek at some of the footage that we have, because I think it's really exciting. So just to give you some context, we've been building a rocket, which we call Phoenix, and it's going to be able to fly up to around 10 kilometers or so. We wanted to launch it at EUROC, which is the European Rocketry competition. But we unfortunately didn't get selected for that competition. So now we have to try to launch it ourselves. But that's another problem for another day. But we did some hot fire testing, which occurred at Lampleshausen, which, if you remember, is actually where the Vinci engine is also tested, which is the one that is taking the second stage of Ariane 6 all over the place today. So this hot fire actually takes place. This takes place at the M11 test stand, and this is our engine, Phoenix. And just to give you some context, it's a hybrid engine, so it uses nitrous oxide as the oxidizer and paraffin wax as the fuel, which just is in solid form in the combustion chamber. And this was our full duration burn. So it burns for about 15 seconds. 8 of it is like the powerful phase, and then the other 7 is when it goes into gas, and then it is a little less powerful, and it makes that big, huge flame there. But yeah, we had lots of success on this test. We were able to get actually 7 hot fires in, and they were all 100% successful. And yeah, here you can see the nozzle. See how much the nozzle glows? It's just like the Vinci nozzle engine, except ours, you can see, melted a little bit. The Vinci engine didn't melt, so yeah, we still have a little bit of work to do to figure out how to actually solve that problem. But yeah, we had in the end we got a thrust of 8.7 kilonewtons, which is one of the most powerful engines that has actually been developed by students. It's not the most powerful, but it's the most powerful this year, so it's quite interesting. Here you can see that we wanted to know what the mass flow rate was coming out of the nitrous oxide tank, so we actually just use a scale. So here you can see that, like, you know, we can tell just by looking at the scale, like how much oxidizer is in the tank. And if you look at it during the burn, like, you can see how the needle is moving, and we can kind of just visually track how much oxidizer we're using. So if you want a low budget way to know your mass flow rates, this is the way to go. But yeah, if you guys have any questions about our engine, feel free to let us know. But yeah, this is kind of like the layout of the test facility there. It's like on a hill in kind of a forest, which if you think about it is kind of a silly place to have a test facility, because it means there's like flammable things everywhere. But yeah, it's the way they do it. Here you can see we actually put a thermal camera onto our tank so that we knew what the fill level of the nitrous oxide was. And it actually works really well. You can see like there's a clear line that delineates where the liquid is and where the gas is. So you can like see the vehicle as it fills. And that's how we're able to tell whether the vehicle is full or not. So another great way to determine these types of things. Really recommend it. Just using the thermal properties of the nitrous oxide to figure out how much you have in there. This is my favorite view. This was actually my camera. My cell phone was sitting right above the combustion chamber, and you can see, yeah, it makes quite a good show. We'll have a video coming out in the next couple of weeks. We're in the process of working on it, where we're going to go and talk about all the details of how the test went and what the results were, and maybe share some more of the test footage and things like this. So if you're into it, definitely check it out. Anyways, moving on. If you guys have any questions, please feel free to let me know, or any comments, any thoughts on our testing or on what's going on with Ariane. We're going to be coasting here for another, I think, 20 minutes or so. So looks like we are now actually flying over Northern Europe, but not quite close enough that you could see it from Bremen, unfortunately. Yeah, if you're in Scotland or like Norway or Sweden, maybe you can look up and see the spacecraft flying over. It's at a good time of the evening to see it, because it's maybe not so dark because the sun is low in the sky. Yeah. When I said before that that basically the trajectory, you can see the trajectory in the yellow. You see how it has that hump there, right? That is now you see the vehicle is starting to plateau and starting to go back up again. The reason for that is that we are right now, I don't think we're actually in a circular orbit. We're actually in a bit of an elliptical orbit. So it's going to actually oscillate between its apogee and its perigee. And this is just a consequence of the way that the vehicle is actually designed. Because that Vinci engine is not super powerful, it's not really able to put you straight into a circular orbit like a Falcon 9 could, for instance. So it kind of has to do this like hump trajectory in order to give it enough time so that it can build up the sideways velocity to make sure that it stays in orbit, which is a bit of a unique thing that is unique to the Ariane 6 vehicle. Also, on that topic, this is the reason why it would be very difficult to man rate the Ariane 6, because when you go onto that steep trajectory at the very start, where basically you're just going into the hump, if there ever was a problem where something went wrong with the booster, or for some reason the launch escape system was triggered, the problem is that when you come back and re-enter the atmosphere, because you don't have a lot of sideways velocity and you're mostly just coming straight down, there's a lot of extra heating and g-forces that come on top of that. So that really kind of limits your design solutions for how you handle that and make it survivable for a human crew. So this is why Ariane 6 probably won't fly people, at least in this configuration. They'd have to do something with the engines to beef it up or something and make it more powerful. If you actually looked at the design for the Atlas V and the Starliner capsule, as Atlas V launches the Starliner, it actually needed to make design modifications because it also has a relatively weak engine, the RL-10. The RL-10 is kind of like the Vinci. It's also an expander cycle engine. And it's very efficient, but again, not that powerful. So it also goes into this weird hump trajectory. And so they had to actually beef it up a little bit, put more engines on it. So now it has 2 of those engines so that it can actually not have such a big hump, and it can safely take the people to orbit. Yeah, so that's a little bit of an explanation of how that works and why man rating maybe is not the best idea for Ariane 6. It's not really what it's designed for. Once the rocket gets over the Asian region, I think it's going to end up flying basically over the Indian Ocean. That's where they're going to do this second ignition and continue the operations. And that's going to come in about 20 minutes. So just to recap for those, if you're joining the stream now, just rewind a little bit by about 20 minutes. Ariane 6 did successfully launch, so it was able to get off the launch pad very easily with great camera views, I might add. So definitely worth a rewatch if you just joined. And in a very shocking form for Ariane Space, they actually have cameras all over the vehicle. So another great thing about the stream is that they were able to capture a lot of the moments that you wouldn't have captured on Ariane 5 because they didn't put any cameras on Ariane 5. So I'm very happy about the fact that they have actually serviced the live stream community a little bit and given the vehicle some flair with the cameras. There are great shots that we got of the booster separation. So we saw the booster separate from the vehicle and like fly away, Falcon Heavy style. They also had a camera on the core stage just looking down so you could see it all the way going until the stage separation. They also had a camera inside of the interstage so you could see the separation of the core stage and the ignition of the Vinci engine. And the ignition of the Vinci engine is actually kind of creepy because the exhaust is so it's colorless. So because it's hydrogen and oxygen that's being mixed, the gases that are produced are just water vapor, and in space you can't see it. So the only thing you see is that glow from the engine. Yeah, so definitely worth checking out, going back and seeing what's going on there. We will see the engine reignite. I don't think they'll be a very long ignition though. The orbits they're going into probably aren't significantly different, but there's still a little bit more that the rocket will do. Coming back to Astra a little bit and the testing that we're doing, in line with the recent propulsion test that we had, we actually are having a review now. It's going to be in about 2 weeks time. So it's going to be between July 22nd and July 26th. We're going to basically have an open review. So all the systems of the rocket are going to be talked about, and we're going to have a complete critical design review process. So if anyone is interested in joining that, we will post some links in the description most likely, and anyone can join. So if anyone wants to be part of the process and figure out all the intimate details about what's going on with Astra Systems, be sure to check it out. It'll all be happening in the afternoon in Germany time, so if you're in America, then it would be in the morning. I guess that kind of sucks. But if you're in Europe, it's nice. yeah, we kind of want it to be like an open process where there's no secrets with the Astra mission. So all knowledge is free for everyone to know and to share. I want to try to how shall I say? I want to make it more accessible, the things like rocketry and, you know, performing propulsion testing and how to design a rocket and things like this, because I think there's like this big gap in people's minds. They think that rocket science is this big, huge, complicated thing, but in reality, you know, there are complicated things, and there are definitely challenges, but you know, there's always ways and paths that you can find solutions to your problems. So we have a lot of strange, unique things that we do. The scale here being one of them. This was our fancy way to measure the mass flow rates on the rocket. And yeah, sometimes you think it's kind of silly and gimmicky, but in the end it works really well. So yeah, if you want to see a lot of the data that we processed and our performance values and all that kind of stuff, then yeah, it'll be at the CDR. There'll be more on that in future releases that we'll put on social media. So if you follow us on other things like LinkedIn or Instagram and stuff like this, we'll definitely put releases and links to all of the reviews. This is our thermal camera that we used to determine the level in the tank, which worked even better than we thought it would. So sometimes crazy ideas like work better than you think. Also, if you're curious, the little octopus that you see on the test engine all the time, her name's Octavia, and she is always with Astra during the testing, and she's going to be the first payload for the Phoenix vehicle. So she's our guinea pig. Yeah. All right. So Ariane is still flying over. It looks like the middle of Eurasia at this point. It's going to be doing some maneuvers in about 15 minutes. So we are just waiting until that is ready to occur. What I'd like to do right now is I just want to go back and actually look at some of the launch footage that we got, and maybe just speak to a couple of things that were happening, because I think they're quite interesting, and maybe we may have missed them because we were so excited. All right, I'm gonna stop the live part. I'm just gonna go back to the earlier parts of the launch. Where were we here? So yeah, right here. So you can see here that the engine starts, and like it's going, and it's going a lot before that we actually see the solid rockets ignite. And if we just play back a little bit here, I just want to point something out. You'll notice that the Vulcan engine also runs on liquid oxygen and hydrogen, so its exhaust is also transparent. So you see here the engine is on right now, like it's fully on right now, and you see that you can't see any exhaust coming out of the engine. And that's because it's just water vapor. And the only reason why you see this this glow, I guess, at the bottom here is because that's actually a mock diamond. So that happens when the gases come back together and they get really hot, and then they glow like this. So that's a mock diamond, but the exhaust here is also transparent, so you actually can't see it. So yeah, the engine goes, and then we see the lighting of those solid boosters, and the solid boosters just totally overpower the Vulcan engine. And also, they're the only thing that's visible because, of course, the rocket exhaust from the Vulcan is transparent. And we have these great tracking shots as the vehicle ascends. And you see it just fly to the clouds. And this is when we realized that they actually have an onboard camera. They're going to switch here pretty soon. It's actually a perfect day for a launch. It's quite gorgeous at the launch site. Yeah, here you get the onboard camera, and you can, yeah, they've never had an onboard camera before. This is actually the first time that they put one on the vehicle. So definitely a plus. Ariane Space, never look back. So here, this is actually a great shot, and you can really tell the difference between the propellants that are being used. So in the solid boosters, they're using solid propellants that use aluminum, and the aluminum, when it reacts, it glows, like, and it creates really colorful flame and with a lot of heat. So there's lots of heat in the exhaust, and that glows really big in the infrared. But yeah, you can see here the stark difference. The center engine is on right now, but you just can't see it because it's the exhaust is transparent. Yeah, I find that so cool. I could just look at this, and you can also see in this shot here, by the way, that if you just walk back a couple of seconds, you can tell that the exhaust from the solid boosters is actually expanding. And the reason why that's happening is because of the atmospheric pressure changing. So at lower elevations, there's less atmospheric pressure, so the gases don't expand as much after they come out of the nozzle. But once you go higher up, the nozzle is still expanding the gases to the same pressure, but now there's less pressure in the atmosphere around it. So the gas continues to expand even further and further. So that's why you see that plume getting wider and wider and wider. And we're coming up now to this point where those solid boosters are going to get jettisoned. This is just really, they should make sure this camera is on every single mission. It is just fantastic. It's also crazy to think that those little tiny solid boosters, because they look kind of small on the side, but they're actually doing the most of the work right now. And kudos to the people who did the tracking shots, because they are really doing a great job, I have to say. It's a fantastic job. And there you see the separation of the boosters, and you see them both falling away. And here, yeah, here you see it from the onboard camera, and it's a little bit of a delay, but still worth it. Okay, I want to just go back for a second there. How do I do this? Come back a bit. So when we're on the onboard camera, one cool thing about these boosters, and when you watch it from the onboard camera, just take a peek here. There's actually two little rocket nozzles that are on the top of the booster, and they're going to activate as soon as the boosters separate. And the reason for those rockets on that part of the booster is to push the side booster away from the core stage. And you're going to see them activate. It's kind of tough to see because it kind of pixelates when this happens. I mean, it's a kind of a dynamic event, but you'll see those boosters fire. If you see them just on the side there, they're firing, and they're pushing that booster away from the vehicle so that it doesn't get a collision. You can also see during this phase, and I think it's quite interesting what happens here. Sorry, I'm keeping on backing up on the same thing. But this is such a dynamic point, and there's so much that's happening in this at this phase. You'll see as soon as those side boosters separate, the vehicle, the core stage, is actually going to change its orientation. So you see those boosters separate, and then all of a sudden the core stage actually pitches up. And the reason for the pitch up is because when you're flying on the side boosters, there's so much thrust to weight ratio that even though you're flying kind of mostly like partially sideways, there's enough thrust going in the Z direction, up and down, that you can kind of compensate for the fact that you're not actually pointing upwards. So basically, because the rocket is so powerful, it can get away with flying at a shallower angle. But now that you've lost those boosters, and because the Vulcan engine is not as like literally the whole engine configuration, the thrust goes from 10 meganewtons to 1.3 meganewtons. So like the thrust is like cut by almost like 85%. So now it has to go into a higher inclination in order to make sure that the vehicle doesn't start falling out of the sky. So this is kind of what happens when you're designing with a hydrogen-oxygen system. You have to kind of have some weird paths in your trajectory in order to get yourself to orbit. And this is what creates that hump trajectory that I was talking about before. And you'll see that on the yellow graph once we get to it. But yeah, and then we're just following that center stage all the way up. Mm-hmm. It's crazy that they're able to track it this far. Like, it's like hundreds of kilometers away from the launch site right now, and they're still able to see what's happening. If you just go back there, man, we missed something. My apologies. So, let's go back a little more. So you'll see now the fairings are going to come off. There's like a little bit of a white smudge. You can just barely make it out on the tracking camera. There they are. Do you see the... Where? There they are. Boom. You see them right there? Those are the fairings coming off. It's like it was barely noticeable. And they might have it from the... Do you see them coming off in the... No, you don't. The core stage camera can't see it. But you can see there's a little smudge that's wandering away. Barely visible in the tracking camera. Yeah. But yeah, it gets rid of that payload fairing because it's there to protect against the atmosphere. And you can see them flying away there in the core stage. You see the payload fairing just flying away? So the reason why they get rid of it is because it's there to protect against atmosphere when you're in the atmosphere, of course, and keeping the payload safe. But once you're high enough up, like at this point we're at 132 kilometers altitude, so you're high enough up that you don't need to protect against the atmosphere anymore. So you can get rid of that extra weight. You're fighting against the rocket equation. You want to try to get your mass down as much as possible. So if you don't have to take that weight all the way to orbit, better just to get rid of it. So that's why you get rid of the fairings. So then, yeah, the vehicle is just climbing and climbing and climbing after this point. Standard procedure. And then we unfortunately don't get so many of the of the core stage. The reason why you don't get as many you can't get tracking shots because it's too far away. At this point, it's like 400 kilometers away. It's too far. But you also don't necessarily get the core stage camera because you're getting further and further away from the tracking site. So you might not acquire signal. And we're literally flying right over the Atlantic Ocean on this trajectory. So it can be difficult to maintain a live feed. But we do get the live feed in some places. Where do we separate? You can see here, again, you can look at the orientation of the vehicle at this point. Like it's almost pointing straight up. And the reason for this is because it needs to get the the whole vehicle up high enough so that the second stage can have enough time to burn so that it can get enough horizontal velocity. So it's going to actually fall after this point. And that's why you need to have this super steep trajectory while you're flying. And this actually cuts efficiency because like ideally you want to follow a straight path when you go to orbit. So you want to just slowly turn over and mostly maintain like a horizontal, like going towards a horizontal trajectory as soon as you get into space. Like this is the wrong orientation to be in if you want to be doing it the most efficiently. But because the engines are weaker, they can't do that. So here we should have the separation. And remember, there is a 20-second delay in the camera, so it will come in a few seconds here. But the core stage will basically be pushed away from the second stage, and then the second stage will have the chance to ignite, and then it goes the rest of the way. And you'll also see here that there will be an orientation change, because now that the core has done all the work to get the payload up, the second stage is actually going to tilt back over and start doing more of the horizontal velocity addition. And hopefully, I think it's going to switch soon here. Yeah, so the camera orientation will switch soon here, and then we'll get the view of the, yeah, here. So you see it separates, and then you see how the orientation of the, look how the orientation of the second stage changes. So it starts to tilt back over, and then now you'll see the nozzle start to glow. That is indicating that the engine has started. But you see how much it tips over, and now we can actually see the Earth on the terminator line. So there are really some very large orientation changes during this whole launch, and that is all around the fact that the actual vehicle doesn't have the strength to get itself all the way to orbit without the core stage doing that crazy orientation change. All right, I think we're back. Ready to start doing maneuvers soon.
Great to have you with us. Thank you.
It's a pleasure to be here.
It was an absolutely incredible launch. Ariane 6 performed like clockwork, and even the clouds parted and gave us clear skies for a beautiful view.
Really magical moment, and this liftoff just had set this mind-blowing pictures, so I lost everything I wanted to say and just enjoyed the show. I hope you did as well. We could see the separation of the two boosters. We are flying an A62 today, so with two boosters we could upgrade to an A64 version with Ariane 6. That we actually separated 2 minutes into the flight. Then we saw the fairing opening, revealing our numerous passengers to the environment of space. And a bit less than 8 minutes into the flight, we had separation of the main stage and the first ignition of the novel Vinci engine on the upper stage. The Vinci engine then burned for about 10 minutes, and since then we've been in coasting phase, which will last about 38 minutes. And right now everything is nominal, as we heard also during the break. And soon coming up is the second boost, so the first re-ignition for the Vinci engine. And we were tracked by Lucknow in India, hello India, during the break, and are now getting close to the north coast of Australia actually.
Indeed, and if anyone who's not familiar with the information on the top of the screen, we've got on the left-hand side the trajectory, that's the planned trajectory, and the white cross is the actual position of the launch vehicle. And then on the right-hand side, you can see our altitude, 550 kilometers above our planet, heading to low Earth orbit. We've travelled nearly 19,000 kilometers if you were to draw a straight line across the Earth from the pad, and Vitesse.
So for this burn, it's actually just going to circularize itself. So right now it's in a bit of an elliptical orbit, and it's going to circularize itself, and I think that's to deploy the first set of payloads into an orbit that will be around 500 kilometers in altitude.
Yes, so you're right. At the moment, the Vinci engine is off, but when we are in coasting phase, the auxiliary propulsion unit, the APU, is actually running, and we heard the DDO saying that it's running nominally, which is very good news. And this piece of equipment is what makes Ariane 6 so versatile, as it is the key to the reignition capability of the Vinci engine, actually. What it does, it uses fuel of the two main tanks and can create a small thrust, a constant thrust, as it has two little thrusters mounted on the rear side of the upper stage. So what does it actually do? We need to manage three things to prepare the reignition. One of the things is the tank pressures. Second thing is the tank temperatures. And we also need to look for the position and the quality of the fuel. And so to illustrate this last point, position of the fuel. The fuels on board, they actually, once we are in orbit, behave exactly like astronauts. So they would be floating in space, so they would be floating all around. And this is not exactly what we want them to do. So we need them to stay close to the tank bottom to be able to guide them then towards the engine for reignition. It's a little bit like if you were preventing your champagne glass from spilling while you're running. So this is a bit the job that it actually
Very important thing to be able to
Don't
do.
lose your champagne. So the APU actually creates a little bit of artificial gravity. And the second point I mentioned was about temperature. We need to avoid the propellant evaporating because that would mean a loss in performance. So while the sun is shining on the rocket, it heats up the tanks, and if the propellant then touch the tank walls,
Acquisition de la télémesure par la station de Nunorcia.
So we have acquisition of New Northa in Australia. Hello, Australia.
Ah, the engine turned on.
The second job of the APU is actually the tank pressure management.
And this is the scheduled moment here for the switching on of the Vinci engine.
Deuxième allumage Vinci.
Wow. We have
So
confirmation
it's
that
working.
Vinci has switched back on. That means the APU has also done its second job in repressurizing actually the tanks, which was what I was about to explain.
And the circularization is
amazing,
done.
amazing. So we could save a lot of helium actually.
So just to be clear, what happens there is the jargon they're saying about the APU is that it's a system that's designed to actually help the engine start again. So the engine can't start, it can't start, but if you start the engine and the fuel's all floating around and everything, then there's a chance that you could suck in air or just gas into the engine, which is dangerous for the pumps because the pumps take in just gas, then they could have a risk of cavitation and that could kill your system. So you have to kind of get all the fluid to settle at the bottom of the tank where the inlets are into the engine. And that's why you have those little thrusters which give the vehicle a little bit of artificial gravity, so to say, and that allows you to be able to start the engine again.
Nominal.
Everything nominal.
Everything nominal.
It's mind blowing that we got here without any hiccups. This is a great achievement, I can say.
So it looks like
is
everything is
indeed,
good.
and,
They're in
I was
orbit.
just saying one of the features of Ariane
perfect
6
orbit.
is really having the flexibility, if you like, to deliver any type of satellite to any type of orbit.
So now that the vehicle is now that the vehicle actually did that circularization, you'll notice that the yellow line is now flattening. That means that the altitude is staying the same as they traverse across the distances on the planet, which means that you're in a circular orbit. So now they have the opportunity to be able to deploy the payloads. And they're also going to ignite the engine again in about an hour. And they're going to deploy the second set of payloads in a different orbit. So they're going into 2 different orbits on this one mission. And this is the key advantage that Ariane 6 has, that it can do. The Ariane 5 couldn't perform a mission quite like this. It could still deploy multiple payloads, but it couldn't put them into very different orbits because it couldn't reignite the engine. So this gives a huge boost to Ariane's capability, and hopefully it will make it more competitive in the market. So at this point, I'm not going to keep the stream going for another hour to see the second burn. But if you want to follow along, Arianespace is hosting, of course, the live stream themselves, and you can check back in with them to see what's going on. I highly recommend checking out the footage of the launch. It was quite incredible, and they had great camera views of the whole launch process as it happened, which is a first for a live stream for Arianespace. So glad to see that they're continuing to improve what they can offer to us enthusiasts who want to see rocket launches. Anyways, thanks a lot for following along with me, and I hope that the launch inspired you a little bit today. And if you're interested in rocketry and stuff, do check out our channel. We do have lots of amateur related rocketry content where we go into how exactly we build our rocket and how you can do these things on a budget and do it in a way that makes it possible for just common people to do this type of stuff. So anyways, thanks for following along. I hope that you're able to continue expanding your horizons.